Hello, my name is Nelson Tam from Kernel Labs. You might recognize me from a video that I did earlier where I talked about the OKL4 driver framework. Today I'd like to talk a little bit about the trusted computing base. Now before I begin, I'd like to note that I'll be using the acronym TCB to refer to trusted computing base exclusively. That happens to clash with another operating systems term called the thread control block. So I won't be talking about that today, so please bear with me for the term overload. Now, what exactly is the TCB? Every computer system has a set of hardware or software components that has the potential to affect the overall system security. By definition, a bug or an exploit in a TCB potentially can affect the overall system security, while a bug or an exploit outside the TCB can only have its impact in a localized part of the system. So for example, if you have a faulty piece of RAM, basically all the claims that you make about data integrity goes out the window because your RAM is faulty. On the other hand, if you have a faulty LCD panel, the impact is going to be much more limited. Since the TCB has such a high stake in the system security, usually extra effort is put in to ensure that it is correct. Ideally, you want your TCB to be perfect and completely bug-free, but in reality, that's usually not the case. In fact, anyone who's written software knows that it's very hard to get perfect software, and usually people have to entrust a bit of confidence in their TCB, knowing that it's not 100% bug-free, but just hopefully that it's good enough so that the security properties of the system is maintained. After all, not everyone who runs a Linux web server scrutinizes the Linux kernel, or Apache for that matter. They just trust that it is good enough. So what do we trust about the TCB? In the context of operating systems, the OS has two roles. First of all, it manages the resources between applications and also provides a hardware abstraction for applications. So when we trust the OS, what we mean is we trust that it provides a well-defined hardware abstraction, and also it manages space and time resources well across applications. You might also want to add to the list that you want to control the data flow between applications if you want to. Now, at Kernel Labs, we understand that just because the kernel is part of the TCB and just because we trust the kernel, doesn't mean that it is trustworthy or doing its job properly. There are two broad categories of mistakes at this level. It's either broken by design, or the implementation of the kernel could be buggy. Now, I don't want to talk too much about how we come up with a good kernel design, except by noting that we learn a lot from our past experiences. And we have been doing OKL4 related research and development for about 15 years to date. And that we also have been building on decades of microkernel research. And we always strive to use the best software engineering practices out there, so it's a continual process. But I actually want to talk a bit more about how we come up with a good implementation. That is, how do we improve the quality of our code? Now, if you consider the number of bugs that can potentially be in your TCB, it's really a function of the bug density that's in your code, and also how much code there is. Now, so we attack it by two fronts. First of all, we make the size of our TCB, the code in our TCB, small, and that's measured by lines of code. We also try to decrease the density of bugs in our TCB. Being a microkernel-based system, OKL4 has actually got an inherent advantage there. We start off with a very small code base. Last night I counted, there's about 15,000 lines of code in our TCB. Now that compares very well with Linux, which measures 10 million lines of code. We even have smaller versions of OKL4 called OKL4 Nano, which measures way less than 15,000 lines of code. Now, we also perform a lot of testing. We start with coverage testing, which means that we basically ensure that every line of code and every logical code path is executed by our testing suite at some point in time. Although it doesn't mean that every code path is logically correct, but it does help unearth a lot of bugs. And it guarantees that there's at least one input for every code path that is correct and valid. And it has proved to actually catch a lot of things such as dead or stale code, which is useless in our code base, and that's very useful. Every night we also run thousands of unit and functional tests while we are asleep, and that also helps catch a lot of defects in our code. We are very aware that testing only helps to uncover the presence of bugs, but doesn't prove that there's an absence of bugs. So testing is not the only method that we rely on. We also do things such as static code analysis. We use tools such as linters to look for poorly written C statements, and that's also proven to be very useful. We have like software processes that ensures that every line of code that we check into our code base is free of lint errors. And we also conduct code reviews every time we check our code into our code base. Now, although code reviews are time intensive, but that's actually been very useful in improving the quality of our code and actually teaches our engineers to write good code. Finally, we are adopting a novel approach called formal verification. What that does is we start off with a mathematical and unambiguous specification of our kernel, and we actually compare that with our implementation, and we use formal methods to prove that our implementation logically matches with our specification. And that technique is actually more commonly found in hardware design, and it's never been done before in operating systems. And once that's complete, it's actually going to give us a much stronger guarantee than anyone could ever have done, and certainly a lot stronger than most of the certification out there. So in conclusion, operating systems kernels is always going to be part of the TCB in any computer system. And we at Open Kernel Labs is very serious about delivering the most secure and the most reliable and the highest quality operating system kernel that you can find. If you don't believe us, you can always check out our source code, and you can find it at www.ok-labs.com. See you next time.